Before I talk more about lists, I want to take a detour into this new concept called mutability. It's a concept that you'll see come up in many of your future computer science classes and in this class. I like to start thinking about new concepts by defining the meaning of the word, or figuring out what the actual word means. So that's where mutability, the root word here is mutable. Well, what does mutable mean? Well, mute, able to mute. But where does mute come from? It actually comes from the root mutate. So mutate able, which just means able to mutate. And mutate means to change. So the word mutable means able to change. And mutability is the property of being able to change. And so far, all of these core data types that we've learned, they've all been immutable, meaning you couldn't actually change the value. You could only replace the value with something new if you were storing that value in a variable. Let me say that again. The previous data types that we learned were all immutable. You might hear me saying that and think, huh? I didn't think so. Wasn't this an example of mutating an integer? When we had something like, some existing score that was an integer, and we would maybe add to that score, so score plus 7. Doesn't this change the value of score from 2 to 9? So isn't that mutating the number? It's a great question, but no. And the way we can tell is, look at this assignment. The way that we execute this assignment is we first evaluate the expression score plus 7, and we create a new integer, the integer 9 in this case, 2 plus 7. So this expression here, score plus 7, evaluates to the number 9, and then that number 9 replaces the existing value in the variable score via assignment. And so we start off with a frame that looks like this, with the score equals set to 2. And then we actually just replace that score entirely to 9. It's not like we're updating the existing number, that something about that number changes. We actually get rid of that number and put in a new number, the number 9. But that's not all objects are like that in Python. Some objects are mutable, meaning that you can change their value. So what's actually stored inside that object after the object is created without having to replace the whole thing. And the exciting thing here is that lists are the very first mutable type that you're learning. So let's see mutability in action. What does this mean? Well, the simplest example of mutability would be you can update some of the items that are in the list. And you don't have to reassign the list. You don't have to create a new list that gets assigned to the variable grades. You can actually update that list directly. And the way you do this for updating one value in the list is with indexing. And so you're already used to indexing for getting a value out of a list. If you have indexing happen on the left side of an equals sign, so on the left side of an assignment, if you have indexing happen, then the value on the right side will get assigned to that index in the given list. So here, we print grades before this assignment, and it's 95, 70, 92, because that's what is set up here. And then we do grades 1 equals 90, which sets index 1 in this list to 90. So when we print out, instead of 70, we see 90 there at index 1. It's kind of cool. You can do the same thing with slicing if you want to update multiple values at once. So if you have same, grades equals 95, 70, 92, if you do grades 1 colon nothing, that's the slice. So everything starting from 1 to the end, and you provide a new list that you want to replace that part of the list with, it will update this grades list. Doesn't create a new one, it updates the existing list, because lists in Python are mutable. You can see 95, 90, 100 gets printed. Okay, I'm going to go through a handful of more handy functions that you can use to mutate lists, and then we're going to practice. You'll watch me practice some of these concepts in Replit, and then you'll actually apply them in class. So other ways of mutating your list. You might want to add items to the end of the list instead of replacing an existing item. And to do that, you can use the append function. And so doing list name.append here, so this first line creates an empty list. Items.append 7 will add the number 7 to the end of the list. Items.append dindu then adds dindu to the end of the list. And so at this point, after executing the third line here, items is a list with 2 items in it, the number 7 and then dindu. And then sometimes you might want to add a item to the list or an element to the list that isn't at the end. You might want to add it somewhere in the middle or at the beginning. And to do that, you can use the insert method. And so insert takes an index and an element, and it will stick those into, stick that given element into the given index and push everything else back 1. And so here, actually, I'll show you in Replit. If I come over here, I'll make a new file. Whoops. Stop. Hi. And I want to show for this example what happens. As we go through here, if I print items in between, I run this code, you see, so the first time we print is in line 2, and we print out an empty list. Then we print a 7, then 7 dindu. And then after inserting at index 0 the element true, we see that true is now at index 0, and 7 got, everything else got pushed back. So 7 is now at index 1, and dindu is at index 2. Finally, on this slide, the last useful thing is if you want to get the number of items in the list, you can use the len function. So length of list name will tell you how many items are in the list. Now that's how to add things. What if you want to remove them? There's 2 main ways to remove items from a list. You can use the remove method of a list, which is when you know exactly which item you want to remove. Or you can use the pop method of a list, or function of a list, to remove an item at a specific index. So here, items.pop1 is going to get rid of, remove from the list, whatever item is at index 1. So here it's dindu. And then we see if we print out and reference that items variable, there is the number 7, and true has moved up 1 spot forward because dindu has been removed. And then if you call items.remove 7, so this remove function, you tell it which item you want to remove. You don't say where it is in the list. The remove function handles finding that item, the first place that exists in the list, and it'll remove that item from the list. So items.remove 7, before our list was 7 true, and then afterwards our list becomes just true. Another common question you'll ask is, does our list contain something? And here we can use this in keyword again. Don't get confused. The last time we saw this in keyword was as part of a for loop. We had for variable name in sequence. Here, when it's not part of the for loop, in is actually kind of like an operator that takes on the left something to look for, and on the right a list to look through, and it will evaluate to true if the item exists in the list, and it'll evaluate to false if the item doesn't exist in the list. So here, for example, the string dindu appears in my TA list, and so dindu in TA list evaluates to true, whereas the string vijay does not appear in my TA list, and so vijay in TA list evaluates to false. Now I've already shown you this, that slicing works for our lists just like for strings because they're both sequences. They're both types of sequences. I just want to point out here that slicing makes a shallow copy of the array. And so it's not the exact same array, it's a new array. And so if you print out all but one TAs, you'll see it says Jonathan, Dindu, Braden. If you were to print out the TAs variable, you would see it still looks exactly the same. So by slicing 1 through the end, you create a new list with just the items that are specified for the slice. Okay, I know this is a lot of information, but for the last slide of these list functions, I'll just go rapid fire and show you some handy functions that you can use with lists. There's a max function, which given a list will give you the maximum integer in that list, the maximum number in that list. So here we have 5, 6, 12, 9, 4. If we call the max function and give it a list of numbers, it will give us back the largest number, so 12. Same exact thing for min. So min numbers gives us the smallest number, which here is 4. And you can even do something very handy like sum, which gives us the sum of the numbers in this list. So 5 plus 6 plus 12 plus 9 plus 4 is 36. Finally, one more handy thing is if you want to know the index of a particular item in the list, it might be handy if the order of items matters. Maybe you have your favorite fruits here, so apple, banana, orange, and you want to know what is is banana your first favorite, or is it second after something else, or third? You can get the index of a particular item by calling the name of the list dot index and passing in the thing that you want to look for. And this will return the index of that item in the list. If the item doesn't exist in the list, I believe it returns -1.